Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to discuss about various performance metrics in machine learning. In my previous video, I have already discussed about confusion metrics. I do recommend all of you to watch that particular video first before moving on to this one so that this particular video will make more sense. And also, before moving ahead, I do recommend all of you to subscribe to my channel, like this particular video, as well as connect with me on LinkedIn and Instagram, and I will leave the link in the description box. So when we talk about performance, right, whenever we have to evaluate the performance of our model, we can use accuracy, we can use precision, we can use recall, we can use F beta score, true negative rate, ROC and AUC. So these are the different ways in which you can evaluate the performance of your model. Right, and related to this, I've already explained confusion metrics, which is very important to understand in order to understand all six of this. Now, when you talk about accuracy, right? So in the confusion metrics, I have already explained to you the concept of true positives, true negatives, false positives, and false negative. Right, so whenever we evaluate the accuracy of anything in general, right, what is accuracy? Accuracy is the number of correct values divided by the total number of values, right? So in case of model, it will be the total number of correct predictions divided by the total number of predictions, right? So the accuracy becomes the true positives, right? So the true positives are nothing but the actual value was true and even the predicted value was true, so that is nothing but that is the true positive. So when you talk about the true negative, the actual value was negative and your model has also correctly correctly predicted it as a negative. So that is a true negative divided by, the total number of values that your model has actually predicted, right? So that is the accuracy. Now remember that accuracy cannot be used in case of imbalanced data set. So when I say imbalanced data set, so for example, let's say your data set that you're trying to train your model on is something like let's say zeros and ones, right? So let's say your data set has a total of 100 values and 95 values are all zeros, right, and only 5 values are ones. So in that case, that data set is called as an imbalanced data set, right? So accuracy is not a very correct measure in that cases. So in those cases, we specially go for a precision or a recall. So when we talk about precisions, so true positives divided by the total number of true positives and false positives. So that gives you the precision. Now what is the precision? Precision is nothing but the total number of true positives that you have got, right, from the total number of true values, the positive values. So total number of true positives that your model has correctly predicted out of total number of positive values, right? So the total number of positive values will be how much? They will be the true positives, the ones which your model has predicted, and the false positives as well, right? So that is the precision of your model. Now similarly, there's another concept of recall. Now recall is nothing but the total number of true positives divided by total number of true positives plus false negatives, right? So how many false negatives were there when your model predicted the true positive? So these are the the formulas specifically for precision and recall. So whenever the number of false positive have more importance, right, in that case we go for precision. So whenever the false negative has importance, in that case we go for recall. So let's say spam, not spam, right? The same example that I took in my previous video. So let's say if an email comes, right, if it is a spam email and your model correctly predicts it, it's fine. But if it is not a spam email, but still your model predicts it as a spam, then it is a problem for us, right? So basically in that case, what happens is your false positive, basically if your false positive has a lot of importance, because if an email is not spam but your model has marked it as a spam, then it is a big problem, right? You don't want it to go to a spam folder. If a email is not spam, right, and it is marked as a spam, then it is a problem. But if your email is actually a spam and it is marked as not spam, then in that case it is still possible that you can watch the email and then you can mark it as spam later on. But in that case, precision is very important, right? False positive is very important. So that is why in that case you will use precision, and in other cases you can use recall where false negatives are important. So that is a little bit of tweak between the precision and the recall. These are the the three performance metrics that you can actually use. And similarly you have something called as F1 score. Now what is this F1 score? Now there are situations where you can use both precision as well as recall, where false positives as well as false negatives are important, and as well as you cannot use the accuracy, right? In those cases you will use F1 score. So F1 score is nothing but it is the harmonic mean of precision and recall. So if you look at this particular formula, this is nothing but this is F1 score formula: 1 plus beta square into your precision value into your recall divided by your beta score into precision plus recall. So this is your F1 score. Now when you will use F1 score, you will use it when you cannot use accuracy, especially in case of imbalanced data set, when both false positive as well as false negative both are important, right? In that case you will go for F1 score. Now in F1 score the beta value will be 1 when both FP and FN are important. Your beta value will be 0.5 when your false positives are more important than your false negatives. Your beta will be 2 when your false negatives are more important than your false positive. So basically I hope you understood this F1 score a metric as well. Now similarly you have something called as ROC and AUC. Now ROC is nothing but the receiver operator characteristic, and AUC is nothing but the area under curve. Now remember that there is something called as false positive rate, right? False positive rate is nothing but FP divided by TN plus FE. Your false positive, it is the rate of your false positive, right, divided by your true negatives plus false positive. Now all of this is coming from confusion metrics, so you will not understand anything from here if you don't understand the confusion metrics from the previous video. So false positive rate, and then the recall, right, that we have learnt just now, the recall, the true positive divided by the true positive plus false negative. Now these rates, right, when you try to plot these rates, and whenever you will plot these two rates, right, so you will plot them for a particular threshold value. So if you look at this particular graph, right, the true positive rate is on y-axis and the false positive rate is on x-axis. Now for a particular value of a threshold, you will actually see that how this graph is plotted. So the more the area of this curve, right, will be, the better your model will be. Now this particular graph is called your ROC graph. It is called your ROC curve. It is called your receiver operator characteristic. So the plot between your false positive rate and your true positive rate is nothing but your ROC curve. It is nothing but your receiver operator characteristic curve. Now more the area of this curve. Now area of this curve is also called as AUC, area under curve. More the area of this curve is, the better your model is. Because if you see over here, right, now let's say for every model, let's say if you do not need false positive rate, right, if you do not need false positive, then in that case you will actually see that the value of your true positive rate will be more, right? If you look at here, the 0.5, right, so at this particular point you can see a false positive rate is 0. So you will always want your model to be more closer to the true positive rates, right? Now in that case you will see the area of your curve will be little higher in case of your true positive rates having more weightage. So if you look at here, if your graph has less area of the curve, now in that case you can actually understand that it is just randomly predicting your data, right? That is why this ROC curve should have a better curve with more area under the curve. So if you go to the left side over here, you will see that is why it is marked as better, because more the area is, the more your ROC curve is there, the better your model is, and it is plotted for different threshold values. So if you look at over here, right, if anybody says, like, if you are deriving a particular model and you understand that okay, I don't need false positive rate, that does not matter to me. So you will see that okay, if false positive rate does not matter to me, then in that case, when false positive rate is 0, what is the threshold for which we are getting the true positive rate? So that is how we actually define our model. So this is nothing but this is your ROC or AUC. So you can actually derive it, especially in case of binary classification. So this ROC and AUC is specifically derived for the binary classification problem. So your binary logistics, when we will implement the hands-on, that is the time I will show you how we are actually using this ROC and AUC during the model performance. So I hope you like this particular video. Do let me know in the comment section if you have any doubts or queries, or if you want me to explain a particular topic little more in detail, then I'll create a separate video out of it. And thank you so much for being till here. Do remember to like, share and subscribe to my channel.